Okay, so the classes that I send in the group, you should find where to keep them because I'll start deleting them from my phone. So they are taking up some space. Sometimes when I delete, they may also be deleted in your, I don't know how it works. Or maybe you have not downloaded them, you can lose them. Okay, you can switch off your video, Shibara. Okay, so logarithms. So let's begin it this way. Let's begin with indices. Okay, indices. Okay, so with indices we have, Chibala, can you switch off your video and switch off your mic as well? I'm fading. How am I? You click on the video down there and then you click on the mic, it will go off as well. Good. So if you want to ask a question, you click on the mic. Currently switch off your mic now. You click on it, then it will have a cross. Switch off your mic. Yeah, click on the mic there, then it will go off. Okay, good. Unless you want to ask a question, feel free to interrupt. Raise your hand. You click on the hand symbol there. I'll be able to see your hand and I'll be able to point at you. You'll be able to ask your question whenever you have any question. Okay. So we begin with indices. So if we have, let's say we have multiplication, okay, under indices. So when we have, let's say a to the power m times a to the power n, okay. So here, when we are multiplying and we have the same base, what do we do with the powers? We write the same base, then what do we do with the powers? Quickly, let's move. Quickly, if you respond, I'll appreciate. Just click on the hand symbol and then it will show that you have the answer. Then I'll quickly point at you, mention the answer. So when we are multiplying same base, Brandon, what do we do with the powers? Come again? The powers. Correct. So we add the powers. So we're going to have m plus n. That's what we do under multiplication. So we go quickly, we go to division. Okay, so under division, when we have a to the power m over a to the power n. So quickly, what do? We have a, which is the common base there. This is the base, this is the index. So the same base, we write the base down there. What do we do with the powers? Quickly, someone else to pick it up from there. What do we do with the powers when we are dividing? Okay, I would appreciate if someone else picks it up. Yes, Joshua, use your hand next time. Yes, Joshua. We subtract the powers. So which one are we going to subtract from? Is it n minus m or m minus n? M minus n. Good. So m, the one which is on top, minus the n. That's what we do. So we also have is it power rule or something? Yeah, power rule or something, if I'm not mistaken. Where if you have a to the power m, then to the power n. So this is going to become a to the power what? Yes, Jibala. Quickly, Jibala, quickly respond. Okay, it's going to be a power mn. Good. So we're going to have mn. That's what we are going to have there. Correct. I hope you can put down your hand, Jibala. Put down your hand. You click on it, it will disappear again. Good. Okay, so this is what we have. Now, this may look this simple and straightforward as it is, but it's of great significance to the topic that we're dealing with, which is logarithms. So we'll need this information. So whatever information I'm giving you is important in the sense that it will help us to attempt. Mind you, from here, we're going to tackle different questions from different past papers. So for you to understand how to solve those questions, you may need this background. That's why I'm giving it. So we need to understand the background nicely, and we need to follow each other nicely, so that when we start solving the questions from different past papers, we are okay. We know where we are coming from. So if you have somewhere to write and you know you can write as fast as possible, record this. You can write down a few things here and there, but don't miss my explanation. If you are unable to write and get the explanation, then don't write. It's better you understand, because I'm recording this video, I'll still share it with you. Okay, so we are done here. Unless there are any questions, we are moving to something else. Unless there are any questions, we are moving to something else. Yes, Liseli, I've seen your hand.
So there's nothing like a plus a to the power something plus a to the power something. There's nothing like that. Addition and subtraction.
Come again. I'm not getting your question.
As in like adding a to the power m plus a to the power n. There's nothing like that.
You are saying a to the power what?
M
M plus.
No. As in like adding the way you're showing us division.
O plus a to the power n. This one you can't add. That one you can't add. Okay, Derek, you are welcome.
Even subtraction, we can't subtract.
No, because these are not, we don't use the bases here in this case. We need to use the powers. So if we had, for instance, we had m here, then we can say a to the power m plus a to the power m is going to be 2a to the power m, because they are common. Okay, so if we have different indices, then we can't do anything. If the powers are different, then we can't do anything. It's like you have x to the power 5 plus x to the power 2. There's nothing you can do there, unless if you want to factor out the x. You can't add them. Hope that is helpful, and thank you for asking.
Yes, it's okay now.
Great. Any other question before we move? Feel free. Nangu mchinyanja mungafunse, we'll still get you. Apart from Lozi, I may not understand Lozi. So Nyanja, Bemba, at least you can express yourself, or even Tonga, will be able to understand. Okay, so we move. So if I'm moving too fast, you tell me I'm too fast. Yeah, because for me, in my mind, I'm thinking we need to cover more. In these 2 hours, we need to finish this topic. When we are teaching you in class, you say, no, sir, we can't finish a topic in 2 hours. But I think here, you guys have already had something, so it's okay to finish the topic in 2 hours. So now, let's say we have 10 squared is equal to, what is 10 squared? Derek, what is 10 squared?
It's 100.
Good. So 10 squared is equal to 100. Okay. 10 squared is equal to 100. Now we need to write that one in form of a log. We need to write that in form of a log. So now in form of a log, it's going to be log 100. This 10 becomes the base, is equal to, this 2 is what you put there, is equal to 2. Okay, so if you have a calculator near you, you can press log 100. It will give you 2. Someone, just to confirm, if you have a calculator nearby, press log 100. Then try to confirm with us. Anyone? Yes, Joshua. Come again.
It's 2.
Good.
Log 100.
Good. Log 100 is 2. Now, let me tell you how the 2 is coming about. You may need to solve these logs without using a calculator. So log 100 is equal to 2. How is it becoming 2? So here, log 10, your calculator is programmed to base 10. Your calculator is programmed to base 10 only. It doesn't have any other base apart from 10. Now, when you have log A, log base A, log base A, log A base A, this one will give you a 1. So long these two are the same, you get a 1. Okay? So long these two are the same, this gives you a 1. Now, yeah, this is standard. You may need to take it the way it is. So here we are saying if we have log 100, we can easily say log base 10. Now this 100, we can write it as 10 squared. So it will be 10 squared. Okay, 10 squared. Now, the moment we have these two are the same, here I was saying it is 1. Why? Because 1 is the power of this a here. This a is to the power 1. So the moment you have these two are exactly the same, you pick the power as your answer. So your answer is a 2. Okay, logs are very simple and straightforward. So whenever you have anything like this or whatever you have, so long you're able to express it where these two are exactly the same. It may not be 10, it may be anything. So long these two are the same. Like for instance, we can have log 5, log 25 base 5. So this one, you can simply say, okay, here we need to convert this to 5 squared. So this would be log 5, then we have 5 squared. So because these two are the same, we pick the power as our answer. So the answer is 2. Now, I don't expect you to start pressing your calculator and say log 25. When you press on your calculator, you want to find log 25, you are simply finding this, which is not what we are looking for. Why? Because I said your calculator is programmed to base 10. It's not programmed to base 5. So you may need an additional trick for you to be able to unlock the log 25, the log 25 to base 5. But the answer here is 2. Without a calculator, because you just need to have these two exactly the same, then you pick the power as your answer. Simple. Okay. So now I hope you are okay how we have moved from this to this, from this to that. I hope everyone is okay with that. Unless there's anyone who is not okay with how we have moved from that to this. This is now in log form because, yeah, this is in log form. So if you are to express this in form of a log, it becomes like this. So this 10 becomes your base. This 100 becomes your log, which you are looking for. Then this 2 becomes your answer there. That's how you work things out. Unless if there's any question. So you may need this information when solving the logs. So you need to understand how to move from this log to that, or how to move from this to this, how to switch. You will need that information. So sometimes when you don't have this information, you may end up failing to find the correct answer. So I'm saying you need this. Okay, so let's try this one. Let's try this one, and I want to see who is going to give us the correct answer. When you have the answer, you simply raise your hand. Let's say we have 8 to the power 3 is equal to 512. Okay, so who can give us the answer for that one? In form of a log. How is it going to be? I can start for you. Log. Yes, just raise your hand if you're able to pick it. We are writing that in form of a log. What would be the base? What would be the log we are looking for? And what would be the answer? Yes, Brandon?
Log 8, 512 is equal to 3.
No, which one is the base between 512 and 8? Which one is the base?
8.
8 is the base. Then 512 is equal to what?
3.
Good. Correct. So that's how we transform that into a log. Okay. So now you may be wondering, but how are we getting this? Because this is not to base 10 and your calculator may not be able to give you to base 10. So it means you may need to change the base. Okay, you may need to change the base the base to 10 so that it suits your calculator. So the formula for changing the base is simply when you have log base A, log B of base A, then you want to change the base, this base, you want to change it to C. So this is going to be log. Now you are putting your base here as C because that's a new base. Then you say over the same log again, then you put your new base C. Okay, so because we are changing to log base C, so I've written log base C, log base C. The here numerator log base C and the denominator log base C. Now see what I'm going to do next. So I'll get this B and put it here. Get this A and put it there. So I have changed the base. Very simple and straightforward. Okay, so we have changed the base completely. So if you want to work out this one, we'll ask Joshua who has a calculator or anyone else with a calculator to help us and confirm that our answer is 3. So if you want to work out this one, what we're going to do is we're going to say we need to change the base to 10. So we're going to say log base 10 over log base 10. Then on top we put 512. 512. Down we put 8. So this must be able to give us a 3. So kindly confirm, Joshua or anyone with a calculator. So on top, just punch log 512. Then you give us the answer for the top part. What do we get? Log 512. And then also log 8. You give us the answer. Then we divide. If you want, we can help you to divide. Yes. Yes, Joshua. What do you get on top?
Log 512 gives 2.7.
It gives you 2.7. Just like that.
Well, there are other denominators. Like I just rounded off to this third significant.
So last time, I don't know if this is the class we are discussing. You don't round off at this stage. You write all the numbers. If there are 20, you write all of them. The down part also, you write all the numbers. If there are 100, you write them down. Then you round off only in the final answer because you run away from the correct range, because usually answers have got ranges. They range from this point to the other. So the more you round off, you may drift away from the answer and you may end up being marked wrong. Okay, so 2.71. Then down there, what do you get?
No, sir. So then let me give you the full number then.
Okay, it's okay. It's okay for now. It's okay. Let's try to see. It will tell us even if we're going to drift away from the answer, then it will prove the point I'm trying to say. If it will give us the correct answer, well and good. Let's use this one for now. So 2.71. What do you have down here?
0.9.
9 what? 93. So when you divide the two, what do you get?
90. Sorry, sir. 0.903.
Okay, 0.903. 0.903. So when you divide, what do you get? Yes, Joshua, we are waiting.
I get 3.001.
So you get 3.001. Okay, so does this confirm our answer here?
Yes.
Exactly. Okay, so but we worked it out and then we said this can be written in form of a log so that what is this side is equal to what is that side. So also here 8 to the power 3 will give you that. So what is this side is equal to the other side. So if you work out this log, you get a 3, which is exactly the other side. So that's the whole concept there. Okay, unless if there's any question, you may need this one. This one, you need it so much. Yeah, this you need it so much. So there's a lot that you need. So don't abandon, don't forsake, don't forget all those things that I'm mentioning to you. Okay, so are we ready to move forward? Can we move?
Yes, sir.
Great, 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 great. Okay, so let x is equal to a to the power m and y is equal to a to the power n. Okay, so we have those two. Then we need to write them in form of a log. Then what would be this in form of a log? Log, I want the base, I want the log, I want the answer on the other side. Yes, can I have different hands? Should I point? Yes, so the good part here is we may not even know each other. This is online, so there's nothing to feel shy about. So we can, yeah, just shout the answer. Okay, so okay, Brandon, I'll still allow you. Yes. What are we going to get?
So we get log A.
What is A? Is A the base or what we are putting here?
The base.
A.
Then we get M as the number, the base that we're putting, the number that we're putting there.
Here.
Then is equal to X.
Okay. Joshua, is that correct? You don't think so? What do you think is correct?
I think the X and the M need to be in different locations.
How? Which different? You mean they have to be swapped?
Yes, I think.
Okay, who is confirming that? Chibala, is that your position?
I'm still thinking.
This early?
I'm not sure, sir.
Derek?
I'm also not sure.
Okay, Brandon, have you changed your mind?
Yes, the X and the M need to swap.
Good. So these two needs to swap. So if you understood how we moved, so here we need to have x, here we need to have m. If you understood how we moved from 10 squared is equal to 100 to simply log 100 is equal to 2. If you understand how we moved there, then there shouldn't be a problem here, how we are switching that one. Yeah. You know, this one which was squared becomes the base. The power becomes what you equate there. This number becomes what you are dealing with here. So the same comes here. The power is what you equate. So the power comes here after the equal sign. Then the number that had the power becomes the base. This becomes the base. So A becomes the base. Then the x becomes the log you are looking for. So log x to base A is equal to m. I hope that helps. So here we're going to have log base is A. What are we going to have here? Literally, what are we going to have here? I'm sure now you know.
Yes, now I've understood.
Yes, what are we going to have here?
So they were going to have y equals to n.
Good. Good. So I'm giving you a lot of work, and one thing I like when I'm teaching is I like as much as possible deriving the formulas, explaining how things are coming about to my students so that they can never forget. Should you forget the formula, you should be able to come up with one because you know how to do it. Okay, so that's how it should be. Okay, great. So now we have those, we have this and that, this and that. we need that information so dearly. Yes, as we move on. Yeah, as we move, we need that information so much. Remember also last time I said when you have log 10 squared, what did I say your answer is when these two are the same? What should be your answer? What did I say should be your answer here? Yes, Joshua. Okay, Brandon, yes.
The answer there should be the same as the power.
The 2. So this power becomes your answer when these two are the same. Let's not forget all those facts. Okay, so now let's move. We are going to look at multiplication. So there are basic rules of logarithms. There are basic rules of logarithms when you are multiplying. So we have changed now. There we are looking at indices when you multiply, but now we're looking at logarithms when you multiply. So when you are multiplying logarithms or logs, so let's say for instance we have log to base a of x times y, xy. Okay, log base a of x, y. So now this one is simply going to become this is equal to, so we're going to have log base a. What is our x here? It's a to the power m, right? A to the power m times, we are just replacing here x and y. The y is a to the power n. A to the power n. This is what we have. So from here, now we're going to have log base a. Then here, when we multiply the same base, we add the powers. So we're going to have a, we're going to have m plus n. Okay, we're going to have m plus n. Now, when you look at this, you see that these two are the same. So what should be our answer there if those two are the same? The base. What should be the answer? Yes, Brandon?
M plus n.
So our answer becomes m plus n. Now, we know our m is log a, log x to base a. So we can replace. So this becomes log x like this. That's our m. Then our n becomes log y. So now what are we dealing with here? We said we have log xy. So this is the rule under multiplication. So this rule simply says when you have log a, then you're multiplying x times y. You can decide to split them this way. That's what this rule is talking about. So you can write log base a, you write your x, plus log y base a. So you can split this way when you are multiplying. Any question? Boom. Any question? Any question? Any question? Yes, Chibala.
Okay, so which one is the answer now? Which one is the final answer? Is it m plus n or that one you are
So our m is this log x base a. Our n is log y base a. So we replace the m, this is our m. The n, this is our n. So what this is telling us to say, because here we have log base a of x and y, x times y. So when you have something like this, you can decide to split this into log x of base a, which is this, plus log y base a, which is that. Now, all this that we are doing, I just want you to appreciate where this is coming from. I didn't just want to say, okay, log a xy, you can, it's as good as is equal to this log x base a plus log y base a. When you're multiplying, you put plus here. I didn't want to go that way, so that's why I'm expressing all this so that we can understand how this plus is coming about. So when you are multiplying xy here, the base is 1 here is a. This is 1 log, but xy are multiplying, so you can split them this way. So this is what this is all about. So that's why I've circled this one, because that's what we needed to come up with. Is that helpful? I need a feedback.
Yes, that was maybe
Come.
another example.
Okay, so this is just the formula. So we have not done any example. This is, we are deriving the formula. We are coming up with the formula. When you are multiplying xy here, you can split it that way. So that's not an example. It's the formula we are deriving. Okay. So Jvala, is that correct? Is that okay?
Yes, yes.
Okay, good. Let's quickly move to division. Let's move to division. So division. So under division, we are saying if we have log, the base is a, and then we have x over y. Okay, this is one log, but here you have x over y. So what should you do? This is equal to, so our x is is where there's x, we can replace with a to the power m. So we're going to have a to the power m over, where there's y, we can put a to the power n, which becomes, since there's the same base there, so you can say okay, I forgot to write the log, so this becomes log a. So we have our x, we are saying it's a to the power m over a to the power n, like that. So this becomes log base n. So here, since we have the same base, so we can add the powers. So we can subtract the powers. So we're going to have m minus n. We're subtracting the powers. So since we have this, they are the same, this one is going to give us the power as our answer. So m minus n. Then now, finally, we are saying log x over y is the same as, so where there's this, you can easily replace. Our m is log x base n, so we have log x minus, where there's n, we're going to put log y. So this is what you have when you have two variables that are dividing each other, or two numbers that are dividing each other like this. You can decide to spread them like that. So you can distribute them like that. Log this, that, which is this, minus log this, that, which is that. So there should be a minus in between when you're dealing with the division here. Any question? Any question? No question. No question? Okay, great. So let's go to the last part, which is the power rule. So we have done multiplication rule, we have done division rule. Now we go to power rule. Power rule. So power rule here, we are saying if you have, for instance, you have log, and then you have x to the power n, like that. Log a, let me use something else here. Let me use p. Okay, log x to the power p. Okay, now this one is going to be equal to log. Now you know what your x is. Your x is a to the power m. So this will be a to the power m, but this m is powered by p there. So it has got the power p. So x, we can replace it a to the power m, but there's a power here outside which is p. So now this becomes log. So I'm going to have a mp there, mp or pm, doesn't matter. mp or pm is one and the same thing. So now that we have this is the same here. Listen, what will be our answer here? Since these are the same, what are we going to record here? Listen, good. mp or pm. So that is what we are going to have. So now finally we can say log. Now mp and pm is just like 2 times 3 is equal to 6. 3 times 2 is still equal to 6. So don't be confused by mp, pm. It's just the same thing. Okay, so we have this x to the power p is the same as, so you can write our p here. What is our m? Our m is log a x. So this is what we have. So you see the same log x a base a is the same log x base a we have here. But here the p is dropped here in front of the log. Here the p is up. So this tells us to say when you're given such a question, you can decide to drop this p and bring it down here. Now, I remember last time when we are solving, what question was that? I've forgotten. Is it APs and GPs? Brandon, you remember?
Yes, sir.
I said you drop this power, drop it here, and then you drop it here and then multiply by the log. I said this will not make sense, but I explained when we are dealing with logs. So this is how the power drops. I hope now it's clear.
Yes, sir.
Yeah, I think from the class we had, I should think everything is clear now with comparing the two. Because there I was just saying there's a rule that says you drop this down here and then we'll drop it and continue working. So this is how it is dropped. So this is the whole explanation. Okay, so where we have reached here, we are not going to do examples, just mere examples. We are going to go direct to past papers and use past paper examples so that we can save on time. Okay, so unless if there's any question, if there are no questions, we are moving direct to the calculations. Okay. So question number 1 came from so we have, this is 2023 November, December, which this is AEE question 4. Okay, so this is the paper, the question that we had. So it had find the value of x. I've forgotten the question exactly. I think I just copied what we need. So we are simply finding, or we are solving, should say solve. So I have 2 to the power 2x plus 3 plus 2x plus 3 is equal to 1 plus 2 to the power x. Okay, now you can try on your calculator. I forgot to mention to you that log 1 is 0. Okay, that is how your calculator is programmed. Log 1 is 0. Okay, so now here,